Hey guys, this is Mrs. Butcher, and this video is about adding and subtracting rational expressions. So let's start with some basics like 2/3 plus 1/3 equals. So we all know that 2/3 and 1/3, we add the 2 and the 1, and we keep the 3 in the denominator, and we have 3/3, and of course you can simplify that to 1. Or if we didn't have the same denominator, like 1/6 plus 1/3, then we would need to get a common denominator before we could add our fractions. So 3 and 6 both go into 6. Therefore, I'm going to multiply this fraction top and bottom by 2. That keeps it's still the same because we're multiplying the top and the bottom by the same thing, but now we have 1/6 plus 2/6. It's like the opposite of reducing your fraction. But now we have a common denominator, so now we can add the 1 and the 2 all over the 6, which gives me 3/6, and that reduces to 1/2. So now let's try an ugly one. Let's try one with expressions with x in here. I've got x divided by x minus 2, and then I have minus 3x minus 1 over x minus 2. So notice that I do have a common denominator. So I'm just going to subtract across the top. We've got x. We have minus. And then you have 3x minus 1. And it is very important that you put parentheses around that 3x minus 1 because you are subtracting all of it, not just the 3x. So we want to make sure that we distribute our negative. That's very important. That's going to mess up a lot of people. And then we have over, and then you have your common denominator, x minus 2. It just repeats. So now on the top, I have x minus 3x, and then minus 1 is plus 1 over x minus 2, which when we combine like terms, x minus 3x is negative 2x, and then we have plus 1 over x minus 2. And that is as simplified as it's going to get. We also need to remember that you can't divide by 0, so therefore x can't be 2. So that has to be part of your answer. X cannot be 2. Alright, here's one. It's just 1 over 2x squared plus 5 over 4x. We don't have a common denominator, so we have to figure out what do both of these have in common. And when you do that, split it up into the constants and then the variables. So we've got 2 and 4. 2 and 4 both go into 4. And then we have x squared and we have x. X goes into x squared because x squared is x times x. So x squared. Our lowest common denominator is going to be 4x squared. In order to make 1 over 2x squared into something with a 4x squared on the bottom, I'm going to have to multiply top and bottom, here I'm going to use a different color, top and bottom by 2. And then I have this plus 5 over 4x, and I want to make that 4x squared, so I have to multiply it by another x. And since you do it to the bottom, you have to do it to the top. So now I have 1 times 2 is 2 over 4x squared, plus 5 times x is 5x over 4x squared. Now that I have a common denominator, I can just put the 2 and the 5x together. So 2 plus 5x on top and 4x squared on the bottom. And then you've got to remember, we can't divide by 0, so therefore x cannot be, in this case, it can't be 0. Because if x was 0, then our denominator would be 0. Okay, now we have 3 over x plus 2, and then minus, and then 8 over x minus 2. So these denominators are different. And because they are adding and subtracting, you have to keep them as a whole group. And that means I have this whole group, and I have this whole group. So those are completely different numbers. Whatever you had for x, if you plugged it in, you'd have two completely different numbers. So our lowest common denominator is going to be an x plus 2. We need one of those. And an x minus 2. So you're just going to use one of each as your common denominator. And that means that I'm going to have to multiply this one by x minus 2 on top and bottom, and this one by x plus 2 on top and bottom to give us that common denominator. All right, so let's multiply that out. We've got 3 parentheses x minus 2 minus 8 parentheses x plus 2 all over our common denominator of x minus 2x plus 2. We don't ever want to multiply this bottom part out. Just leave it factored. Leave it alone. But this top part, because I've got a minus in between here, I want to clean this up a little bit. I'm going to clean it up down here. So we've got to distribute the 3, and we have 3x minus 6. And then I'm going to distribute the negative 8, and I have minus 8x, and I have minus 16. Make sure you remember that's a negative 8 that's being distributed all over the common denominator. And then last, we can combine like terms. We've got 3x and minus 8x gives you negative 5x. And we have minus 6 and minus 16 gives you negative 22. And then that's all over x minus 2 and x plus 2. And we can't divide by 0, so basically if we set our denominator equal to 0, x would not be allowed to be 2 or negative 2 as our final answer here. Alright, here's a new one. We've got 8x over x squared minus 9 plus x minus 7 over x minus 3. The very first thing you have to discover here is you have to be able to look at this and say that must be factored. So that's going to factor to x plus 3x minus 3. We always want to factor everything that we can first. Alright, so now that we've factored that, we have 8x over x plus 3, x minus 3, and we have x minus 7 over x minus 3. And I'm going to go ahead and group these guys. So now we're looking for a lowest common denominator. In this denominator, I have this group, and I have this group. I have 1x plus 3, so I'm going to need an x plus 3. And I have an x minus 3, so I'm going to need an x minus 3. And then in this denominator, I have x minus 3, and that's taken care of right there. So I don't need to add another one because this is common to both of them. So that's my lowest common denominator. Now I need to create that same common denominator in both fractions. So when I look at the first one, I've got 8x. It's already over x plus 3x minus 3. And since it's already over what our common denominator is, we don't change it. We leave it alone. It's fine the way it is. Then I have a plus. And then I've got my x minus 7 over x minus 3. And I need the denominator to have an x plus 3 in it as well. And so I'm going to multiply the top also by x plus 3. So you're not changing it, you're just rewriting it in a different way. Now our denominators are the same. And it doesn't matter if the plus or minus comes first. They're still the same. A, B, and BA are the same thing. So I'm going to combine the numerators. I've got 8x plus, and I need to FOIL this out. So x times x is x squared. X times 3 is 3x. Negative 7x. And negative 21. And that's all going to be over our one common denominator, x plus 3x minus 3. Don't FOIL the bottom out. It's factored and it's not going to change, so we leave it factored. But on the top, we want to combine like terms. So we've got x squared. And then we have 8x and 3x makes 11x. 11 minus 7 is 4x, so x squared plus 4x. And then I have minus 21. That's the numerator. The denominator is x plus 3x minus 3. And then this top one is that this numerator is a quadratic, and it looks like it might be factorable. So we need to check, are there factors of negative 21 that add to 4? And there are, because 21 is 7 times 3, and so we want a positive 7 and a negative 3, because 7 minus 3 would give us 4, and 7 times negative 3 would give us negative 21, over the same common denominator. And then it's not always going to work out this way, but in this case, the x minus 3's can cancel out. So our final answer is x plus 7 over x plus 3. And because we can't divide by 0, just like when we did our multiplying and dividing, you have to look back before you crossed out. And we have to say, well, x can't be negative 3, but it also can't be positive 3. Because even though that canceled out, In the original problem over here, if I put a positive 3 in for x right there, then I would be dividing by 0, and that just isn't allowed. So there's your final answer. Sorry, cross that out. X doesn't equal. Okay. All right, new problem. 3 over x squared minus 5x plus 6 plus 2 over x squared minus 4. And like I said in the last one, the first thing we want to do is factor. So I've got 3 over, and then I'm going to look at this. Factors of 6 that add to negative 5 would be not 6 and negative 1, because that would give you positive 5. Not negative 6 and positive 1, that wouldn't work either, but 3 and 2, or negative 3 and negative 2. So we're going to use x minus 3 and x minus 2. Because negative 3 times negative 2 is positive 6, and negative 3 plus negative 2 is negative 5. Plus 2 over, and x squared minus 4 is a difference of squares, so that's x plus 2 and x minus 2. So now we need to come up with a lowest common denominator. This denominator has an x minus 3 and an x minus 2, so we need those. This denominator has an x plus 2, which that one doesn't have, so we need one of those also, x plus 2. And it has an x minus 2, but x minus 2 is already taken care of right there, so we don't need another one of those. We have one of everything now in our lowest common denominator. That means that this first fraction needs to be multiplied by x plus 2, top and bottom, so that I can have it in the bottom. And this one, the second one, needs an x minus 3, because it doesn't have that yet, top and bottom. Okay, so I've got 3 and x plus 2, plus 2 with an x minus 3, all over my common denominator of x minus 3, x minus 2, and x plus 2. Whew. Remember, leave that factor. Don't mess with the bottom there. But the top, because I've got this plus in the middle of it, I do want to make that 3x plus 6 plus 2x minus 6 over my lowest common denominator. I'm going to cheat a little bit. Alright, so 3x and 2x makes 5x. And 6 minus 6 is nothing, so it's 5x all over. And I'm going to write it because this is my final answer. X minus 3, x minus 2, and x plus 2. So then, of course, we have to know that we aren't allowed to divide by 0, so x can't be. And then we can just look at it and say it can't be positive 3, it can't be positive 2, and it can't be negative 2. So here's your final answer. You have to put the exclusions in there. Those are like asymptotes in your graph, aren't they? So they have to be included as exclusions. All right, we're done. Do some celebrating.